Hello, Jeremy here. This video will cover the computer science concept of encapsulation, and we will update the presenter program to utilize this concept to help clean up the code even more. Encapsulation is the idea that an object should keep its data private and under control. This isn't really a new idea, just the name is new. This way the data the object is working on doesn't change in unexpected ways. Encapsulation is just another way to manage change, just like how immutable objects help us manage change. In the program, we are going to have the object stop writing to the screen and write to their own internal surfaces. Okay, let's do this. So, I have to admit that I recorded this yesterday and I had a recording issue halfway through. I hit the mic volume down in OBS and it totally made the video unwatchable. So I have the code edited already, so I'm going to have to go over that code edit. But to explain what we're doing in this episode, I thought it would be good to pull out the tablet and go over what we're going to be doing first off, and then go ahead and look at the code edits. So go ahead and pull up the tablet for myself. Great. Everything should be ready to go. So I should just be able to draw. Yep. Groovy. Okay. So what we've done in the past is we've had the screen as a surface. My beautiful straight screen. And we've had the program draw on it. So, it'll have a Pac-Man. Pac-Man was terrible. Try it this way. That's better. Okay, so we draw a Pac-Man onto the screen, onto the surface. That represents the screen, and this eventually gets swapped into the video buffer, and we print the image to the screen. This is what we've been doing. We've been solely writing to the screen, the surface, the screen surface. Now, what I want to do is actually have it so each object will write to its own internal surface and manage its own surface. So instead of writing directly to the screen, we're going to write to its own surface. So we'll make a surface, and then this new Pac-Man object is going to write to its own surface. It's going to have a Pac-Man drawn on it. And then, when we want to display what this object has, we just split this onto the screen surface. So it seems like this is an extra step, because it is an extra step. We have another surface, we go ahead and draw it to the screen. What's the point of doing this? Well, the point of doing this is so let's call this like the Pac-Man class. This will be Pac-Man. The point of having the class have its own surface is the class is responsible for this surface, and it can draw to the surface without having other interference with it. That's the principal idea of encapsulation, is this object only should have access to this surface, so it can draw onto this surface no problem. And this also separates the things drawing to this surface. So what could happen is if you have lots of different things drawing to the screen, it can be hard to manage what exactly is on the screen without separating it like this. So the Pac-Man can get blitted from this surface to that surface, and we can draw to the screen by just looking at the surface that this Pac-Man object has inside of it. So it's fairly easy to draw this surface onto the surface, and it becomes pretty uniform. So there's another concept that needs to be covered, and that is the concept of the rect, or the rectangle. And it's really not that difficult. It's literally a rectangle. That defines regions. So what we do when we blit, we say copy the information, the image from this surface onto this surface. But as you can see, this surface is smaller than this surface. So what you can do is you can specify what the region is that you're going to blit, and you use a rectangle to specify that region. So I could say I want to blit from here onto the screen here, but I only want it this big. So what you'll actually see on the display is that this won't be drawn. It'll just be the piece that actually fits in that region. So when you do a blit and you are able to specify the rectangle of the blit, and I'll show you how that actually looks in the code, this is what happens. It only blits like this is the clip region, but clipping out the rest of the image. But just imagine that there's a rectangle like this, and that's what's getting drawn. It's the same way you're saying, only copy this rectangle to here when you specify a rectangle. You'll see what actually happens. And also the rectangle can specify the size of the surface as well. So we kind of have the rectangle do double duty, as you will see when we actually go into the code. And I think it's a good time to go into the code and start applying this to our program, or show the program now. Okay. So here we are. I need to fix the sizing. Okay. Okay. Great. So we'll start with the text typer and the changes to the text typer that I made. So before we specified the screen was passed in, and we had character X, character Y. Now we pass in a rectangle. This is going to be the rectangle that's going to define where on the screen the text typer window is. Like, you can imagine that it's going to be within that region of this rectangle, and the text will be displayed relative to that region, and it will not be allowed to go off of that region. So we can define it super small, we can make it super big, we can define it the size of the screen, and I think I did that. Character position defines where the margins are, so maybe it's better to call it margin. This defines the upper left and this defines the upper left of where the characters will start printing to give the spacing around it. This is equivalent to the character X and character Y that we saw before. These lines, we take the rect. Since the rect is a tuple, it has the X position, the Y position. This defines the upper left of the rectangle, the width of the rectangle, and the height of the rectangle. That is all the information we need to define a rectangle. Character X and character Y define the point where the characters should start. We create a new surface here. So instead of passing in the screen, we are going to make a new surface. So this is the encapsulation portion where we make a new surface that the text typer is going to hold internally into itself. So it can draw and do whatever it wants to the surface. And we're going to take the width and the height of the rectangle specified, and that's going to be it for the surface. That'll give us a region that is big enough, or a surface that is big enough for us to draw on, assuming that it was actually big here. This is all the same. We're going to store the rect. That way we can use it for later. And these all look the same. This has been updated to pass in the new parameters, the rect and the character position. And do the text typer down here. What's changed there? Draw was updated a bit. Instead of blitting to the screen here, we blit to our internal surface. That was the only change that we made. This way, this is where we update the surface on the draw. So now the internal surface has been updated when we do a draw instead of updating the screen. Update is identical. Image didn't really change, except instead of passing in the screen, we are updating our internal surface. This is the same thing. Then we determine the rectangle. Okay, so given the position of the image, the XY, we extract the position. When Pygame loads the image on this line, the width and the height information is stored in the file. So you have a JPEG, you have a PNG, you have whatever, a Targa, and all that stuff. When Pygame loads that image file, the width and the height is stored in the file. So it knows the width and the height. Therefore, we can get the size of the image, the width and the height here, and then we can create the rectangle. That way we know where to paint it on the screen when we do paint it. So the draw has been updated to not blit, and to just say update is false. Don't need that anymore. So the image is pretty basic because a lot of it was already there. A lot of the functionality is done with the load. So that's pretty simple. Then we go to the canvas. This is the thing where we can draw with the circles. This has been changed to, instead of the screen being passed in, we pass in a rectangle. The rectangle defines the canvas region where we want to be able to use the mouse and paint the circles. And we break up the rectangle into XY width height. Store the rectangle, we allocate the internal surface for the width and the height of what the person passed in. We store the mouse position at 0, 0. That way it will start in the upper left-hand corner. When we draw to our internal surface based on the mouse position. And the mouse motion will update the mouse position. And that's it. It's pretty simple. Now we go to the multiplexer. The multiplexer has been updated a bit. Again, the multiplexer has a rectangle. So we're saying the multiplexer is going to be drawn and interacted with in this region. The position looks extraneous. This might actually be, I need to update this to see, do I actually use position anywhere? I don't think I do. I do not. Yeah, we don't need this anymore. Get rid of that. Let's go back to the multiplexer. Down here, because 0, 0 is in the rectangle. Shouldn't require that anymore. So let me save that out and try running it again. That should be great. Yep, cool. Okay. It's always a good thing to be able to just step back and rerun the code after you make a simple change, just to make sure things are working. Okay, let's go to the multiplexer and go through it more. So when I create the multiplexer, I create a 0, 0 surface. And that's okay. The reason why it's a 0, 0 surface, based on this implementation, maybe I should treat it a little bit differently. But the way this was implemented, the 0, 0 surface makes sense because if it does not have any GUI elements underneath it, it's not really going to be drawing anything. And what it's doing is it is using the surface of the underlying GUI element here. This is what's using that. So it's saying, ooh, that's interesting. I'm surprised that works. Well, anyways, it's saying our surface is the surface of the underlying element. So it's creating a reference or a pointer to the underlying surface. So if it's the text typer, this is the text typer surface. If it's the image, it's the image's surface. So this is saying when we draw we'll call the underlying element to draw onto its surface, and then set our surface to the underlying element surface. So it's letting the underlying element do all the work. Okay, so that's draw and update hasn't changed. This should be presented. Okay, so here we've updated these guys so they would work. And the main change is down here in the draw. So we call multiplexer to draw. That updates all of the internal surfaces. So everything draws on its internal surface. And then we take the surface, we take the screen, and we blit the multiplexer surface, and we take the multiplexer's rect. The multiplexer's rect needs to be updated as well. It may need to be changed to the element's rectangle. I wonder. Well, I'll think about that for later, but let's just keep it for now. So here is where the rectangle. When we do a blit, we define this is where we're going to blit to from this surface, from the multiplexer surface, given this rectangle. And this rectangle is the rectangle I showed you from earlier. So let's go back to the GIMP so I can bring back up this guy. The rectangle that we're talking about is this rectangle. No. Come on. It's being cheeky. It's this rectangle. Here. We're talking about this guy. Okay. So that's that. And we do the split like normal. And nothing else has changed. So what this will allow us to do is in the future, we can do different things here. So when we want to draw to the screen differently, we don't have to touch the classes. We don't have to touch the GUI element classes that we've been making. We won't have to mess with multiplexer. We won't have to mess with canvas. We won't have to mess with any of these guys. Because they'll do their own thing. They'll make their own private surface. And then it'll be up to whatever is going to coordinate how to draw those surfaces. It will be responsible. So later on, it may be the case that we want to draw like a background. Then we want to draw, I don't know, like level blocks. And then we want to draw the character blocks, so or the character images. So we may want to draw things in layers, and we'll come up with functionality to do that. And we don't want to have to update these guys to do that. We want to be able to update other things to do that, update something down here, or come up with other objects that can manage things. The multiplexer kind of does this kind of management, but it's really not an element. It's more managing the elements, allowing us to select different ones. So that's the idea, and why we updated this. The next lesson will be on sprites, which is what this is actually leading up to. And you actually know quite a bit about sprites, especially Pygame sprites, because I basically converted these into sprites. So I will talk about sprites in the next video. Have a great day. See you later.